Right. For a couple of days we were doing BGP and we have reached this very important section called BGP path selection. In that we learned that attributes makes this protocol special. We also learned that there are different categories. Some are well-known mandatory, some are well-known discretionary, some are optional transitive, some are optional non-transitive. We have thoroughly understood what it means when we say well-known mandatory. Example here, AS path next hop origin is well-known mandatory. Local preference, it is well-known but it is discretionary. It's not mandatory one. We are going to see what is local preference in some time. Multi-exit discriminator MAD, which is also well known, but we don't call it as well known. The reason is it is only used when we have dual homing scenario. So it comes under optional non-transitive. MAD is mandate. All mandates are well known only. But this is mandate only when there is dual homing. We will see what is multi-exit discriminator today. Then you will understand better why it is coming under optional non-transitive. MED is optional non-transitive. Local preference is well-known discretionary. All the other three that you see here, origin, next hop and AS path, they are well-known mandatory. And this is the topic where we stopped our previous class. AS path is an attribute. I even showed you in GNS3 by capturing the update packet. When an update is sent, the update goes not just with the network information, it also goes along with the attributes attached to them. BGP updates are bigger in size because they carry attributes along with the network reachability. In this example, what we see here is we learned the network 192.168.1.0 from this autonomous system into this autonomous system. That autonomous system gives to this autonomous system. When this autonomous system 65000 receives the network, it receives with the AS path info. The very first autonomous system is the immediate autonomous system which is giving. The last autonomous system number is the autonomous system from where this network is originally advertised. Right? About the AS path we already know. We are not learning here about AS path. We are just learning about the attribute. Next hop is another well-known mandatory attribute. Next hop. So we learned about next hop behavior. Here we are not to repeat the next hop behavior. We learned next hop behavior. We spend 1 or 2 days on next hop behavior in our classes. This is to say that the next hop address is carried. Especially what we need to focus here is when the next hop address is advertised to IBGP neighbor, EBGP address is carried inside IBGP. That's very important point that we should know. Other than that, it's a usual thing. Every routing protocol will advertise a next hop. Now, this is a very important attribute. Origin, origin, origin attribute. Origin means beginning, from where and how it begins, how the network actually advertised. A routing protocol job is to advertise network, to distribute the route information. That's the job of a routing protocol. But we need to tell the routing protocol to distribute it. We usually do in two ways. One is we advertise using network command. Any routing protocol you take, whether it is RIP or EIGRP, OSPF or BGP, we use what? Network command to advertise. Network. We put the network command and say this is the network that you're supposed to process and advertise. That's one way of introducing a network into a routing protocol. In BGP, if you use a network command and advertise, then it will carry I in the origin attribute. I as the origin attribute. I means internal to the BGP protocol. It's internal network. It's BGP's internal. I. There is also E. The routes that are coming from EGP protocol and got distributed inside this BGP will have E. Originally, the route is being advertised in EGP protocol. Yes, it is an old protocol before BGP. Very old routers will have it. We don't have. We don't have in any of our router EGP. But I have seen very old router, but not in production. I have not seen in production anywhere now. So those old routers in BGP, when they speak to, when the network from EGP is learnt and redistributed into BGP, then BGP will show E. That's the marking it will carry. So that anyone who see the network, they will know this is originally advertised by the protocol runs, the router that runs the protocol, EGP. And then comes the question mark. This is normal redistribution. When we take OSPF route or a static route or a connected network, advertise it in BGP, then it carries the question mark so that any router that receives the update will know that this network is actually from some other source, not originally from BGP. See, these are all the markings that tells how the network is origined. It is like a label. This attribute is like a label to inform the receiving router that these networks are introduced like this. Now, this is a well-known mandatory attribute, so definitely you should have at least one of this. Not at least, you will have at least only one of this, and it should be there. Either question mark or I or E something should be there. Right? So the origin attribute informs all autonomous systems. See, very understandable word, very easy to understand word. All autonomous system. Let's say this is the world, and this end of the world, one router is there. Here you redistributed. On the other end of the world, there is one router here. It can tell you that it has been redistributed. In Sydney, you redistribute. I'm here in Chicago. I know that this has been redistributed by a Sydney router. How? Because when it comes to me, it comes with a question mark. So the entire world will know how this network is advertised, how this network is introduced through this small marking called origin attribute. Origin. Why is it so important? This is your autonomous system. You are connected to multiple autonomous systems. This one advertises a network 1.1.1.1 with I. This one advertises with question mark. This one advertises with E. So your router will prefer the small one. I is smaller than E is smaller than question mark. Your router will prefer smaller. So your router will decide to go via autonomous system 10 instead of 20 and 30. In case if you don't have this, then it will go via 30 because E is smaller than question mark. Did you understand? Any question on origin attribute? Okay. Anyone else? Okay. That's great response. The next page is going to tell you about these attributes that we have learned. You see, AS path is an attribute we learned. For each network, you see AS path. After AS path, what did we learn?
Next hop.
Next hop. You have next hops. If the network is locally advertised, the network will have next hop 0000. When the next hop is 0000, weight is also another attribute like next hop, and the weight will be by default 32768. When the next hop is 0.0.0.0, weight will be 32768. Right. Okay, what is the other attribute that we learned? Origin code. You say origin code I, E, question mark. You can find here I. The red one. There are two I actually. The one in the beginning and one in the last. This one in the last is what origin code that you learned. There is another I. This means this network local to this autonomous system. Local to this autonomous system. Not coming from some other autonomous system. You may be receiving from other autonomous system, but it is also available locally here. That means internal. This I means internal. This I means BGP's own network, advertised using network command, not a redistributed network. The red I at the back only means origin code. The I in the beginning means the network is also locally available on the same autonomous system where this router is. Next attribute in our list is local preference. See, so far you have learned AS path attribute, and then next hop, and then origin code. AS path, well known mandatory. Next hop, well known mandatory. Origin code, well known mandatory. What about the local preference? Local preference is also well known, but it is not a mandatory one. It's a discretionary one. It may be present, may not be. When it will be present? When the network is advertised to another IBGP. When the network is advertised to another IBGP. When the network is advertised to another IBGP, this attribute will be going along with the advertisement. This attribute will be sent along with the network as an advertisement. But this local preference will not be sent to eBGP. You see, local preference is used to advertise IBGP neighbor. See, it's not saying eBGP neighbor. Local preference is a value, a number. The default is 100. The higher you give, more it is preferred. For example, in this example here, A has got local preference 200. This information will be advertised to every router inside the 64520, so that all the routers in this autonomous system will know how to leave the autonomous system. C router will decide to go this way. Which way? Via A. C router will decide to go this way. Even B router will go this way only. The reason is this 200 that you set in router A is advertised to all IBGP neighbor. So every router knows that the best exit, the preferred exit is A. Because A has got higher local preference value. B is only 150. So B will not be the preferred exit. A is the preferred exit. This is an attribute which is helping us to tune the outbound traffic, outbound policy. tuning outbound policy. I want all my routers, listen to this word very carefully. I want all my routers in this 64520 to exit like this to reach this network. I don't want to go this way. I prefer going this way. If that is your outbound policy, then you set local preference. Local preference is used to advertise to IBGP neighbor about how to leave their autonomous system. And this local preference is sent only to IBGP neighbor. It is only advertised within autonomous system. Local preference attribute is well known and discretionary. The default is 100. Higher is preferred. Any question on local preference?
No, sir.
Anyone else have got any question? So what we are going to see now is, first thing you will notice that the configuration on XR router is not same as iOS router. Secondly, you will find even some policies need to be written in order to send and receive update. Those are the two things I would like to show you today. XR router will take some time to load, but iOS will come immediately. Now I would like to put this in two different autonomous systems. And now we are going to have some network for testing. So I'll be using loopback. Okay, see XR is loading. It will take some time because it's a heavy device which usually runs on ISP routers, ASR routers. So meanwhile, let's plan. On XR side, I'd like to give IP address on the loopback as 1.1.1.1/32. See, /32 you can give slash on XR device. On iOS routers you cannot put slash. You need to write the subnet mask fully 255.255.255. In XR, slash will work. Okay, so we are going to test EBGP route sharing. I told you that you need to advertise and learn through policy. You need to write policy in order to tell router, permit router to pass the advertisement, and also to learn. For that, we have taken these two loopbacks, and this gig Ethernet and fast Ethernet on the router needs IP address. So let me take IP address here as 12.12.0.1 slash 16, let's say. On the other side, .2. Okay, so let us finish this iOS stuff first. iOS is a well-known story for you all. Enable config T interface loopback 0. IP address is 2.2.2.2. You see here I cannot put /32. This is iOS, it won't accept. You have to write the mask. Host name AS20 Edge. Interface F00, no shed, IP address 12.12.02. Router BGP 20, neighbor 12.12.01, remote AS10, network 2.2.2.2, mask 255, 255, 255. This is how we do in iOS router. There is no change here. Whatever we have done so far, it's the same thing we have done now also. When I type show IP BGP summary, it will be idle or active, because so far that other router is not yet configured. No route, so it is in active state. Next is show IP BGP. It is advertising this network, but there is no one to learn. Let us go to XR device. Most probably XR would have got ready now. Let's see. Yeah. The username is Cisco. Password is Cisco. You see, here it is there, username and password. Config T. Now, please do not attempt to reconfigure the device until the okay. There is some process still going on. As I said, it's a heavy device. Okay, it says configuration completed. I think you can start now. When it says, the system configuration completed, only then you should start configuring. Okay, now I say config T, host name. I'm going to give autonomous system edge 10. You see, the host name is not changing. It's same like Juniper Darsh. You have to commit. See, after I commit, you can see here the host name got changed. Now let us create loopback interface. IP address 1.1.1.1, 255.255.255. See, you can also put /32. But you should not say IP, you should say IPv4. Okay? It's not simply IP. It will throw error. You should say IPv4, IPv6. You should be precisely saying that. And again, this is still not applied, it is just configured. All right, it is still not pushed. Okay, now interface again G0000. See, that's what I see here, the name, and I say no shutdown. IP address, it won't work. IP address, IPv4 address 12.12.01/16. All right, now I'm going to say router BGP 10 address family IPv4 unicast. See, you have to enable the IPv4 support under BGP. For that, you should put this command and come out. Now, the process of IPv4 BGP is started. Now you say neighbor 12.12.0.2 remote AS 20. Right? Next, you go under the address family IPv4 unicast and advertise the network that you wish to advertise. You see, you don't need to type the keyword mask. You can just put /32. Now I commit. You can commit from anywhere. You don't need to go to the global privilege mode to do that. Say I have committed. So I'm expecting now BGP neighbor to be up. Let's verify. The command is show BGP summary. It says BGP is running. Now show IPv4 show BGP IPv4 unicast all. Okay, simply summary. Hey, come on, it shows the same output. Hold on a minute. Show BGP IPv4 unicast okay. You can see that this network is inside BGP. BGP is trying to advertise this network, but still it is not having greater than simple. We need to wait. I want to show you whether the BGP neighbor is up. Show IPv4. No, not IPv4. Show BGP neighbor. Yes, simply straightforward. Show BGP neighbor. Okay, what is it? It says. It says that I have a neighbor 12.12.02. Remote AS is 20. Local AS is 10. So it knows that it is an eBGP. But the problem is no address family configured. Okay. I'm going to go and change in in iOS router address family. Because I set address family on ASR, no, it expects the other router to have address family.
But in the XR we can configure directly without address family.
Address family also we can do that, but In XR, we have a practice of doing address family because XR supports a lot of address families, not just IPv4 and IPv6. So whenever we use XR, we always try to start the address family first. Here also I have to enable IPv4 address family unicast. Inside this I will advertise this network. Network is correct. 2.2.2.2. Mask is mask. I need to activate the neighbor. Yeah, this is what missing piece. 12.12.0.1 need to be activated. That's why you're getting this complaint. Okay, now show IP BGP summary. It's an idle state. Why should I be out? Ping 12.12.0.1. Ping is happening. But still it is an idle state. Active reset. Peer closes the session. Unicast base. Okay. Again, it's same address family issue. I need to go back here, I think, under the router BGP 10. Neighbor. We have done this, right? Good. Yeah. Okay, neighbor 12.12.0.2. This is how it should be. Please note this one because I have not done for a long time with ASR. I missed this piece. You go inside the neighbor and say this neighbor belong to address family IPv4 unicast. Very important. See, there are two places you have done. Look at this. This is simply to activate IPv4 support. This is under BGP mode. But this address family, the same command, it is not under BGP mode. It is specifically under BGP under this neighbor. Okay, do not forget this. When we do many labs in ASR, you will know the difference better. Write to memory and all will not work because we are committing. Now if you go here and check, your neighbor should have come by now. See, the neighbor has come now. So that was the missing piece. But you see, there is no network learned. ASR will not give so easily. You have to write a policy to give. And show IP BGP. This is giving, but that won't be learning. That won't learn. Let me show you. Show show BGP summary. It says, I am neighbor with this guy. I am neighbor with this guy for last 20 seconds, but I did not learn anything. And you see one exclamatory mark next to it? That is what I am trying to tell you. What does that exclamatory mark says? It says, still the policy is not given to me whether to send or receive. Whether to send or receive, no one has given me policy. So, I am not going to give, I am not going to learn. See, show BGP, nothing it learns. It is giving, but the other guy is not receiving it, but sorry, I should not say it is giving. We have asked to give, but it is not giving. Likewise, the other router, we have asked to give, and the other router literally gives. In another class, I will show you, it will give, but XR will not be learning it. XR will not accept it unless you write a policy to learn it. As a result, show route, you don't see route in the routing table to reach 22222. Likewise, on the other router, you don't have route to reach 1.1.1.1. Now, if you want the route to be exchanged, you need to write a policy. You see, when you write router BGP 10 and neighbor 12.12.0.2
So space.
address family, it should be done by under address family. Here, we need to say use route policy. You see this one. We need to use this route policy. Route policy. Let's say ABC. You need to say in and out. To give, you need to say. To receive, you need to say. So I'm going to write a route policy and then come back here. Alright, let's write route policy. Route policy ABC. I'm simply saying pass. Pass is a keyword. It means permit everything. Do you follow? Next.
Yes, sir.
This is not a route map. This is a route policy. Now I have a route policy. Now I am going under router BGP 10 neighbor 12.02 route. Where should I go? Address family. I need to go under neighbor, and then I need to say address family IPv4 unicast. Inside this only you will have the route policy option. Route policy ABC. In means it will learn. Likewise, if you say out, it will give to the next neighbor. Commit. After you do this, you will not have that exclamatory mark. You see, the exclamatory mark is gone and you already received one prefix. What is that prefix? Show BGP. This is that prefix. 2.2.2.2 is learned from this eBGP neighbor, from this autonomous system 20. See, that is an AS attribute, and then this is next stop attribute, and this is origin I. Now, if you go to iOS router, you will now learn the route to reach 11111. Earlier you were not having this. Yeah, last time you didn't have. So in the iOS XR device, we need to write a policy to accept and send updates. Any question?